Hello, in this video, we will discuss about how to decide the selectivity in halogenation. Now, to understand about the selectivity in halogenation, as we know that halogenation of alkane takes place by free radical mechanism, and we saw the example here, say for example, methane when it is reacted with chlorine in presence of sunlight, then the result here is chloromethane and HCl. This reaction is proceed by the free radical mechanism, but in this case there is no selectivity. See here, all the hydrogen of this methane, right? All four hydrogen are equivalent. Therefore, if you replace any of this hydrogen by chlorine, it will result in the formation of same chloromethane. So there is no selectivity. We can extend this discussion for the other molecules, say for example CS3 ethane. You do something like say either bromination or chlorination, say for example bromination in presence of sunlight. Again, the three hydrogen attached to this carbon and three hydrogen attached to this carbon, all hydrogens, all six hydrogens are equivalent. Therefore, you replace any of these hydrogen by bromine, the result will be what? CS3 CS2Br, or bromoethane and HCl. So there is no selectivity in both of these example. No selectivity is involved, or no ratio selection. But however, if you take the example of other molecules, say CS3 CS2 CS3, this is propane. And when we do either chlorination or bromination, say for example chlorination in presence of sunlight, as new. Now here the six hydrogen on this two terminal carbon, like this three hydrogen and this three hydrogen, six hydrogen are equivalent. If you remove one of these, or if you substitute one of these hydrogen by chlorine, the result is going to be CS3 CS2. Says this hydrogen is replaced by chlorine, then this will be 1 chloromethane will be the product. And the other possibility is if you replace one of these two hydrogen from this middle carbon, then the result will be CS3CH. One of the hydrogen is replaced by say chlorine, and you have CS3. So this will be chloromethane. Sorry, 2-chloropropane. I'm sorry about that. Propane. This is 1-chloropropane, and this is 2-chloropropane. Is the are the two possible products. Now the question here is which one will be major product, right? Which one will form in larger amount and which one will form in a smaller amount? That is when we call that as ratio selectivity. There is a two possibilities. Now we wanted to decide which one will form in larger amount and which one will form in a smaller amount, called ratio selectivity. Now, if you think of the statistics here, there are six of these hydrogens there. So based on these six hydrogen, the probability factor, the 1-chloropropane, this product number A, 1-chloropropane, there are six of such hydrogens. So this should be the major product, and there are only two of these hydrogen there. 2-chloropropane should be the minor product. But the statistics does not work here. If you do this experiment and determine their percentage, the ratio here, the 2-chloropropane is formed in near about 60%, whereas 1-chloropropane is only 40%. So that means 2-chloropropane is the major product and 1-chloropropane is minor product. Now, why this is a major product? What is playing the role? Now, in this case, we need to look at the mechanism for the formation of this both type of product and what type of radical is generated. So before we discuss that, you need to be familiar, or we need to be familiar about the types of different types of free radical. Okay, if we have the carbon that is connected to no other carbon, all three are hydrogen, and there is a radical there, we call that as methyl radical, right? Methyl radical, which, and if, and this is a special type of primary radical, it's a methyl radical. But if the carbon is connected to one R group and there are two other hydrogen and with one radical, see this carbon, we call that as the primary carbon. These hydrogens are primary hydrogens, and the radical so generated, we call that as the primary 1 degree, also called primary free radical. And you need to be very comfortable to identify that carbon that has two hydrogen and one R group, one carbon containing group, any group it could be, that is your primary. But if the carbon that that poses the radical is connected with two R group, it can be same or different R, you can put R, R prime or R and R, and only one hydrogen. See, this is the carbon with the radical that is connected with only one hydrogen to our R group. We call that as 2 degree, also called secondary radical. And if the carbon that is with the uh, odd electron or the radical is connected with no other hydrogen but all three are R group, that can be same or different R group, then we call that as 3 degree, also called tertiary radical. And the stability wise, right, so this methyl radical is less stable compared to primary, primary is less stable compared to secondary, secondary is less stable compared to tertiary. In other words, tertiary radical are more stable than that of secondary, secondary is more stable than that of primary, primary is more stable than that of methyl. Okay, so that means what, you can, in other word, tertiary radical is far better than that of secondary, secondary is better than that of primary, primary is better than that of methyl radical. This is the stability order that you need to be aware about all the time. Now based on that, here we can, once we have this tentative idea there, we can go ahead and discuss uh, about the major product and minor product in our previous discussion. Say here, the 1-chloropropane that is formed by the generation of primary radical. So this carbon is primary, this carbon is primary, and if the radical is generated here, that will be the primary radical. Whereas the middle carbon is secondary, and the radical generated on this carbon will be secondary radical. So if we look at the mechanism here, so CS3, CS2, CS3 in propane, this carbon on the terminal, this carbon on the terminal are both are, these two we call that as primary carbon, whereas the middle one we call that as the secondary. So when we remove this primary hydrogen, the radical that is generated will be CS3, CS2, CS2 radical. That will be primary radical. Again, see that this has two hydrogen, only one R group. So this radical, this dot is radical, remember that. That is your primary radical. Whereas if we remove the secondary hydrogen, the resulting radical will be CS3CS. That is where the radical is going to be, and CS3. This will be our secondary radical. And this secondary radical is far better than that of the primary radical from our understanding. So this secondary radical then result in the formation of CH3, CHCl, and CH3. That will be, this is 2-chloropropane is the result of the from the secondary radical, whereas whenever the chlorine radical react with this primary radical, this 1-chloropropane is the result from the primary radical. Propane is resulting from the primary radical. So this is what, this is the reason why this is as the major product. Again, if we need to discuss the mechanism of that, we can proceed in the same way. So the first step is step 1. If we talk about the mechanism, step 1 is chain initiation. That is when chlorine will homolytical cleavage it undergo in presence of sunlight to generate the chlorine free radical, and that chlorine free radical is trigger the formation of the primary or secondary radical. In the second step we call chain propagation step. It will result in the formation of either primary radical or secondary radical. This is, and but this one will be the major, this one will be the minor, and in the termination step it will result in the formation of product. So that is how we can decide what type of product will be formed. So that is the selectivity in halogenation. Now if you do the bromination reaction of the same product, reaction in the bromination, say for example propane, again we react with bromine in presence of sunlight, H nu. The result is, again there are two possible product, CS2Br, and this is 1-bromo propane, and here is CS3CH, CS3Br. This is 2-bromo propane, and again if we do this experiment, around 97% is 2-bromopropane, around 3% is 1-bromopropane. If we do it experimentally, that means there is more, this 2-bromopropane as the major product. And also we can clearly understand that in chlorination the percentage was 60 to 40, so the selectivity is less in chlorination, whereas in bromination it is 97:3. So there is more selectivity in bromination compared to chlorination. That has to do with the energy of activation and so on and so forth. So that is how we can decide. Now in this case we can quickly say, for example, do one very quick practice problem. Suppose you have here, this is 2-bromobutane, and that is resulting from, say for example, this is butane reacting with bromine, and the other possible bromine in presence of sunlight. So if you react butane with bromine in presence of sunlight, two possible product is like a 2-bromobutane, and other is say 1-bromobutane. Okay, this is the result of replacing the primary hydrogen with the bromine. This is by the replacement of secondary hydrogen. So here it is 1-bromobutane, and this is here 2-bromobutane. So these are the two possible products. Now you need to decide which one will be the major product. Obviously 2-bromobutane will be the major product because it is formed by the replacement of secondary hydrogen. This one will